Okay guys, we're going to go ahead and start chapter 11, which is all about probability. And so my question here, have you ever imagined what your life would be like if you won the lottery? So what's the probability that you win the lottery? Well, think about this. You have a better chance of getting struck by lightning than you do winning the jackpot. Aw. Well, we're going to go ahead and talk about probability in this chapter. And the first thing we're going to talk about in section 1.1 is what we call the fundamental counting principle. Okay, so you got dressed this morning, and how many different outfits could you have put on to get dressed this morning? Well, let's say you have 2 pairs of pants and you have 3 different shirts. You could wear blue jeans or you could wear black pants. You could, with those blue jeans, wear a white shirt, yellow shirt, or a blue shirt. If you chose the black pair of pants, you could have chosen the white shirt, the yellow shirt, or the blue shirt. So you really have 1, 2, 3, 4, 5, 6 different outfits you could have actually worn if you had 2 pairs of pants and 3 shirts. Now, what happens if I had 10 pairs of pants and 15 shirts? You could draw a tree diagram just like we did here, but that tree diagram is going to get bigger and bigger and bigger with the more items you have. So what's an easier, more mathematical way of figuring out that we could have 6 different outfits if we have 2 pairs of pants and 3 different shirts? Well, it's called the fundamental counting principle, where we can simply take the number of items pants times the number of items shirts, and that gives us our total number of items, 6 outfits that we could choose, 1 from each category. Choosing 1 pair of pants and 1 shirt from the amount of options that I have to get 6 different outfits. Okay? So here's an example. A restaurant offers 10 appetizers and 15 main courses. In how many ways can you order a 2-course meal? You want to order an appetizer? You want to order a main course? How many different meals could you actually possibly order? Well, we have 10 different appetizers, we have 15 different main courses, and I want to choose 1 out of each category. I can use my fundamental counting principle and multiply the number of appetizers, 10, times the amount of main courses, 15. So we actually have 150 different meals we could have chosen, choosing 1 appetizer and 1 main course. Look at example 2. It says here, this is the semester that you'll take your required psychology and social science courses. Because you decide to register early, there are 15 sections of psychology from which you can choose, and there are 9 sections of social science that are available at the times that do not conflict with those of your psychology. And how many different 2-course schedules could you possibly make with these options? You want to choose, remember, 1 from each category. You have 15 psychology, 9 social science. This would be another example of fundamental counting principle where we can multiply our numbers together, 15 times 9. You could make 135 different schedules with the options that you have. Now, fundamental counting principle doesn't just work when there's 2 items. We can do fundamental counting principle with even more than 2 items. For example, if we had 2 pairs of pants, we had 3 shirts, but now we added shoes into the mix, and now we have 2 different pairs of shoes we could choose. How many different options of outfits could we possibly come up with? Well, you can see that we drew a tree diagram, and if you count each branch of the tree diagram, you end up getting a total of 12. But again, the more options we have, that bigger the tree diagram gets, so it might not always be efficient to draw a tree diagram. So how can we more efficiently get the number 12 different outfits? Well, we can take the 2 pairs of pants, we can take the 3 shirts and the 2 shoes, and we can multiply all 3 of our categories together, getting the number 12. So fundamental counting principle works with not only 2, but it also works with more categories than 2. So look at example number 3. It says here a pizza can be ordered with 2 choices of size. So you get medium or large, 3 choices of crust, thin, thick, or regular, and 5 choices of toppings, ground beef, sausage, pepperoni, bacon, or mushroom. How many different 1-topping pizzas can be ordered? Well, we know we have 2 different choices of sizes, right? Medium or large. We're going to choose 1 out of those, but that's 2 different options. We have how many different crusts? 3 different crusts, right? We're going to pick 1 of those out of the 3. And how many different toppings do we have? And we're going to choose 1 of those toppings. Well, we have 5 choices of topping. We're going to choose one out of those. Fundamental counting principle says we can find the total number of ways we can choose one from each category by multiplying the 2 times the 3 times the 5. We can make 30 different pizzas with the options that we have up there. Okay, make sure you practice your fundamental counting principle. We'll do the second half of 11.1 in the next video. Let me know if you need anything.